Hello and welcome. In this video, we'll walk you through our cloud-based system that looks at how Australians reacted online to the 2025 global tariff hikes when the US raised taxes on imports from China and several other countries. Australia relies on both China for trade, the US for strategy. So, people here were caught in the middle. We collected posts from Mastodon to see what people were saying, and used tools like Fission, Kubernetes, and Elasticsearch to build a real-time scalable pipeline. The data we gathered spans from March to May, covering the key phase of the tariff story, from the initial announcement and online backlash to the trade deal that pulled things back in mid-May. Next, we'll give you a brief overview of the system architecture.
This diagram shows the architecture of our Mastodon analysis system, which run on the Kubernetes cluster for scalability and orchestration. We begin with the Mastodon scraper, which runs on a periodical schedule to fetch public posts from the Mastodon AU platform. These posts are stored in the Mastodon index inside Elasticsearch, serving as a raw data source for downstream analysis. Next, we have several serverless functions, Analyzer A, B, and C, deployed using Fission. Each analyzer performs a different kind of text or metadata analysis, and their outputs are stored in the separate Elasticsearch index. We also include a standalone analyzer, which is used for one-off or ad hoc analysis task and store results into result D. A backend service is responsible for aggregating these analysis results and exporting them through a RESTful API. This API is consumed by Jupyter Notebook, which allow end users, such as data scientists or researchers, to explore and visualize the analysis result. Next, Stephen will introduce the cloud deployment and data collection.
For the infrastructure and settings, our app runs entirely in the Kubernetes cluster, using Fission to manage functions and microservices. So most of the functions used in our project are listed here. They run in self-built custom Python environments to support our analysis and information harvesting logic. And these functions are triggered on a periodic basis to collect new posts from social media and perform analysis. And post and analysis results are stored in our Elasticsearch database, which is also running on our Kubernetes cluster. We can use Kibana to view the collected data. Okay, so as you can see here, we collected more than 2 months of data to our Elasticsearch, and which is roughly around 3 million posts. All the fields are listed here in this index and will be used for analyzing. We also cached our analysis result in the indices here. So now let's have a look at our Kubernetes orchestration. As you can see here, most of the pods are managed by Fission automatically as pulls, but for some like machine learning tasks, we have to use standalone pods for compatibility and performance. Mm, This is a pod we created for sentiment analysis. It runs in a standalone environment built by us. And as for the pod management, we use Kubernetes deployment config to automatically manage pods. Taking the backend pods, for example, it is automatically managed by our deployment.yaml using our self-built backend Docker images. And then we created a service to expose the backend service so our Jupyter Notebook client can have access to the REST APIs. Next, my teammate Kangyu will present the data analysis section.
We began the analysis by examining the number of posts over time. The volume was steady overall, but two sharp spikes appeared around the 3rd of April and the 9th of April. These matched the key developments in US-China trade. On the 2nd of April, Trump announced the beginning of Liberation Day and introduced a 145% tariff on Chinese goods. The new tariff officially came into effect on the 9th of April. China responded with its own 84% tariff on US goods, effective the 10th of April. These back-to-back actions sparked a surge in online discussion. Mastodon users followed and reacted to these events in real time. To understand user reactions, we analyzed the sentiment trends. Using a mini-LM-based model, we scored posts from -1 pro-US to +1 pro-China. Daily average scores leaned slightly pro-US. However, right after the tariff announcement, scores shifted briefly towards China. This may suggest that some users viewed the policy as too aggressive. After looking at sentiment distribution, we noticed that the shift was mostly due to more neutral posts, not a rise in pro-China sentiment. Overall, the community remained more aligned with US views. The word cloud confirmed this pattern. Terms like Trump, tariffs, and USA dominated. China appeared less frequently. This suggests users focused more on US politics. Hashtag analysis showed mostly neutral tags, but some like Trump and Taiwan tilted ideologically. Tags like Election 2026 leaned pro-US, while mental health leaned slightly pro-China, reflecting distinct issue-based communities. Now, I'll hand over to Honghuan Liu, who will discuss the key challenges we faced during the project and how we addressed them.
Our development and deployment experience on the project brought us valuable insights on cloud-based big data analytics. Meanwhile, we encountered a number of technical and data-related challenges. For example, one of the key challenges is how to handle the errors. We implemented a suite of unit tests to simulate both success and failure scenarios of Elasticsearch connection. This allowed us to detect edge cases early and ensure that if application fails, it will return meaningful error messages. Another key issue is how to reduce the risk of a single point of failure. We decoupled the raw and filtered datasets into separate Elasticsearch indices. By this, all downstream analysis and visualization components can operate independently of the massive source data, and improved files isolation, which means that failures or delays in the raw data pipeline do not propagate to the downstream workflows.
To sum up, our system handled real-world data at scale and stayed flexible across components. We worked around challenges like messy social media content, large data volume, and PyTorch deployment limits by separating concerns and using Docker where needed. Looking ahead, we'll expand to Reddit and Blue Sky and bring in stronger models for even deeper insights. Thanks for watching, and we hope this gave you a clear picture of our work.